Okay, so today we're going to talk about one-sided and two-sided limits. You don't know it yet, but so far all you've done are two-sided limits. Sometimes the values of a function f tend to go towards different limits as x approaches a number c from opposite sides. When this happens, we call the limit of f as x approaches c from the right-hand limit. And we call the limit as it approaches from the left-hand limit. There is a symbol to use when you want a one-sided limit. It's a little hard to see here, but to indicate that we want a right-hand limit, all we do is on our approaching number, we put a plus sign above as an exponent of the number there. And that means we want the limit as we approach from the right. So this guy is the right-hand limit. To indicate we would like the left-hand limit, or the limit from the left, we put a little minus sign as the exponent of your approaching number. That's called the left-hand limit. So remember some of those piecewise functions where we said the limit did not exist because it was a jump there? Well, technically, there is a limit from both the left and the right. The limit just doesn't exist because they're not going to the same place. So today we're going to start distinguishing from when there is a left limit, right limit, when those two aren't equal, when they are equal. So that's what today's lesson is all about. We sometimes call the limit as x approaches c of f of x the two-sided limit. So if you don't mean from the left or right, so what you've been doing, what we did in that previous section, all of the homework problems we just went over, those were all asking for two-sided limits. You can tell because there won't be a plus or minus exponent above the approaching number. I usually just get in a hurry, and rather than say find the two-sided limit, I usually just say find the limit. So like I'll say find the limit from the left, find the limit from the right, or find the limit. But it's technically called a two-sided limit. I just never can get those words out when I'm in a hurry. Got it? Okay. And we know that because one of the ways that a limit is destroyed and doesn't exist is when there's a jump. We can also say that the two-sided limit exists if and only if the left limit and the right limit are equal. So that's the only way we know. A limit exists, and if I just say plain limit, I mean the two-sided limit. A limit exists if and only if the left and right limits are equal. Okay, so let's look at this graph that we've been given, and we're being asked to find several things about it. The first one we're being asked to find is the limit as x approaches 0 from the right. It's a little hard to see, but that is a plus sign right there. So we want to find the limit as x approaches 0 from the right. So that means if I'm looking at the graph, I need to take my pen and go to the right side of 0, right? Yes? I can't find 0. It's here. Sorry, that's 0. That's x is 0, right? I had a bad moment. Cut me a break. All right here. This is 0, right? Okay.
Right.
And from the right, where is my pen going as I trace towards x equals 0 from the right?
0.
That is why the right-sided limit is set to be 0. Next, I want to find the right-sided limit as x approaches 2. So as x approaches 2 from the right, that's this x value right here. Do you guys see it? As I try to approach that, my pen never makes it there. What happens?
It cuts off short.
It cuts off short. To get there, I would need to extend out to here, but I don't have that. When it approaches nothing from that side, we don't just give the number that it last approaches. We actually have to be able to continue in on that. So we would say that that one does not exist because there's nothing even there as you get very close. Now, a lot of people want to say that it's 0. But that would be the limit as x approaches what number from the right? 3. That's not the same as approaching 2. To approach 2, I would need to extend out to there. Any questions about part A or B? Let's talk about part C. This one asks us to find the limit as x approaches 2 from the left. Sometimes it may help you if you hold a sheet of paper when you're doing one-sided limits, like along there where the x line's up, and imagine that line. If you're doing a one-sided limit, if you hold a sheet of paper over it, then it cuts off the right side and your eyes can kind of focus. So if we want to come in from the left, if I ignore all of this and I'm coming towards positive 2 from the left, what y value am I going towards? Does it matter that there's a hole there?
No.
So that is the limit from the left. That's why we say it equals 4. Okay, so to finish up this problem, let's look at the limit as x approaches 2. Not from the right, not from the left, but just as it approaches 2, which means we have to consider both directions. So, if I imagine that I'm trying to approach this x value and I trace in from the left, we've already established I'm going to 4, right? But from the right, it does not exist as I approach 2. And so the only way the limit can exist is if the left and right are going to the exact same spot when you trace them. So what is the limit as x approaches 2? Does not exist. And then finally, if we want to approach 3 from the right, that's a plus sign right there. If we want to approach 3 from the right, which I can't, is that right? Yeah? That's this guy. Wait. Is that this guy?
Yes.
Oh, but I'm going left. Ooh, I can't tell my left from right. Okay, which side's right?
This one.
That one. Okay, that was weird. It's from this direction, right?
Yes.
Okay, so I'm going to come in over here from the right. What y value am I heading for? 0. And that's why it's 0. What's 3 from the left? It's not asked us. It doesn't exist, right? Because there's nothing coming in. If you imagine along here, there's nothing coming in towards that x value anywhere. Okay.
It was approaching